Hi, in this video we look at how to solve the quadratic equation using the quadratic formula, and we're going to predict the number of solutions to this equation by looking at its corresponding quadratic function. So here I've got the graph of f of x is equal to 8x squared minus 11x plus 5. You'll notice that this graph does not cross the x-axis at all. That is, when f is equal to 0, we don't have any x-intercepts. So you'd predict that there would be no solution to this equation, because when f of x is equal to 0, there's no points on this corresponding graph crossing the x-axis. That means there's no x-intercepts. So let's go ahead and we'll solve using the quadratic formula. The quadratic formula says that x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So we get that x is equal to 11, negative minus 11, plus or minus the square root of minus 11 squared minus 4 times a. A is 8 times c, which is positive 5, all square rooted, all divided by 2a, which is 8. So all divided by 2 times 8. So if I simplify this, well, I've got minus 11 is positive 11. So I've got positive 11 plus or minus. Now we can evaluate what the number underneath this radical is. And I get 11 squared, or negative 11 squared, minus 4 times 8 times 5, which is negative 39. So I get that x is equal to 11 plus or minus the square root of negative 39, all divided by 16. Now, recall that the square root of negative 39 is not a real number. It's actually the square root of negative 39 is an imaginary number. So I can write this as x is equal to 11 plus or minus the square root of negative 39 can be rewritten as the square root of 39i, all divided by 16. So this gives us two roots. One of the roots is that x is equal to 11 plus root 39i, all divided by 16. And the other solution is that x is equal to 11 minus root 39i over 16. So although we can write this in terms of complex numbers, we don't get any real solutions. So when you have a graph that has the graph of a quadratic function like f of x that has no x-intercepts, you'll get two distinct complex solutions. But notice that these solutions are not real. So we can write that there's no real solutions, but there are two distinct, or two different, let's say two distinct. Distinct just means two different. Two distinct imaginary solutions. Let's say complex. We should say complex. These are not imaginary numbers. These are complex numbers because they're written as the sum of both a real part and an imaginary part. So no real solutions, but there are two distinct complex solutions. So there are two distinct complex solutions. So we can see that we can see that there's a definite connection between the graph of a quadratic function, or a corresponding quadratic function, and its corresponding equation. So when there's no x-intercepts, you get two distinct imaginary solutions, or no real solutions. So we'll see what happens in the next video when we look at a graph that just comes down and it just touches the x-axis. Another thing to note here is that let's look at the value of b squared minus 4ac. So b squared minus 4ac was equal to minus 39. And now negative 39 is less than 0. So b squared minus 4ac was strictly less than 0. So notice that any time that you have a value for b squared minus 4ac being less than 0, you'll get a negative number underneath this radical. And a negative number underneath a radical produces an imaginary number. So you'll get negative b plus or minus some imaginary number, which is a complex number. So any time that you get b squared minus 4ac being less than 0, there will be no real solutions. No real solutions. But two distinct complex solutions. So we'll get two distinct complex solutions. We'll see you in the next video.